In this video, I'm going to go through the steps required to build a Linux kernel for the Beaglebone, and I'm also going to show the steps that are required to deploy the kernel to an existing distribution. I'm then going to demonstrate how you can download a Linux distribution of your choice and deploy the kernel to that. The good news is that as a result of this build, I now have Wi-Fi network access for the Beaglebone over a WPA secured wireless LAN network using two very small €10 USB Wi-Fi adapters. This is the fifth video in my series on the Beaglebone. This video is standalone to some degree, but if you don't know what the Beaglebone is, please go back and view the first video in the series before going through this one. There are follow-on videos that explain how to program the Beaglebone using C++ and how to interface with external devices using the GPIOs and the I2C bus. The reason that I'm building the kernel is because I want to support SPI, and I also wanted to build new drivers for the Realtek RTL8192CU wireless adapter chipset. I managed to get this working using the latest 8192CU drivers on an older Ubuntu and Angstrom distribution, using the drivers that are downloadable for the Realtek website. I thought it would be useful to make a video on that. The funny thing is that while I was making this video, the Ubuntu minimal ARM release and the latest kernel were updated to provide much better support for the Realtek chipset. And both adapters worked after a fairly simple deployment. Neither adapters worked until this point. They could see the wireless network, but they wouldn't associate with it. So I'm not sure how useful this video is going to be. I've had several requests to put a video in place that shows how you build a kernel, but I'm not doing much here that you can't find in the excellent links that I have attached to this video. There's just one other thing to mention. You'll notice that I'm using an external power supply and not the USB cable to power the Beaglebone. This is because Wi-Fi adapters need a surprising amount of power. I'm using a 5V 1.5 amp supply and it seems to work well. Make sure that you have a fairly high current supply or it's unlikely you'll get your adapter to work correctly. So as I said, as a result of this build, I now have Wi-Fi access to the Beaglebone over the network. So after I build a kernel, I go through the steps in Linux that are required to enable two different adapters that are based on the Realtek RTL8192CU compatible chipsets. The reason that I chose these two adapters, the Edimax and Duronic, is that they're very cheap and they're widely available for sale through Amazon. They're both very neat and were less than €10 each. The Edimax adapter, the EW7811UN, comes in a large box for such a small device. It claims to be the world's smallest adapter and claims 150 megabits per second with B, G and N network compatibility. It stated support for Linux on the box, which gave me some additional hope. A quick search of the internet let me know that it was compatible with the RTL8192 chipset. Remember though that if you're watching this video a few months after it was published, the product name might stay the same, but that could change the chipset. The Duronic comes in slightly less environmentally friendly packaging. It too claims 150 megabits per second with BG and N compatibility. It looks to be about the same size, and you can see on the back that it mentions that it has a Realtek chipset. Again, a search of the internet using the product ID told me that it was the same chipset. There isn't too much of a difference between the two adapters. The Edimax one is slightly smaller and seems to have a slightly better data rate on my network. For what it's worth, the Edimax adapter has a blue LED and the Duronic adapter has a red LED, which quite strangely appears to be inside the casing. The Duronic adapter is about €1 cheaper and seems to work very well too. As I said, both devices have the same chipset, so I would imagine that any device that uses the RTL8192CU compatible chipset should work fine too. As you can see here, they both fit very neatly into the Beaglebone and don't increase the footprint size too much. So now for the work. It will take a few hours for you to carry out the steps at the same time. I've sped up the video when downloading packages and compiling to try and make it slightly less boring. I've also used a blank VirtualBox Linux Ubuntu installation, so there was almost nothing installed before I started. The first thing that I have to do is I'm starting with an absolutely clean build here. This is a brand new virtual machine that's never been used before, and I'm running this on VirtualBox. But I just want to make sure that I can go through all the steps cleanly for this installation and that it'll work for anybody who tries. So the first thing we need to do is to install our cross compiler. So that would be, in this case, I'm running on Ubuntu. So sudo apt-get install, and the tool chain that we need is gcc arm linux and gnueabi. Okay, so it's 40 megabytes. Goes through this install. Okay, so it's installing a few tools. So I'll just fly through parts of this install, just each of the steps, just to show that they're run to completion. Okay, so that's run to completion. The next thing I'm going to do is I'm going to build everything in a single directory. So I'm going to make a directory Beaglebone. So an empty directory. Now the first thing we're going to do is we're going to take the build that's been specifically designed for the Beaglebone, and that's we'll use git to check that out. So git clone github Robert C Nelson Linux dev.git. Oh, we have to first install git. That's interesting. I would have thought that was installed by default. Okay, so I'm going to type the same thing again. Git clone github.robertcnelson Linux dev.git. Cloning into Linux dev, so it's receiving the objects. Okay, good stuff. So we should have a directory here now. We need to go into this, and we've got our build here. There's good information here in the README. It shows that this has support for various different Beagle boards and so on. And there is a specific configuration for the Beaglebone. So I'm going to install that. So it's once we're in this directory, you have to be in the Linux dev directory. We'll do git checkout. AM33X minus V3.2 minus B AM33X minus V3.2. V3.2. I made a typo there. V3.2 AM33X. How did I do that? AM33X V3.2 33X V3.2. Okay. So it switched to a new branch. Okay, so that's fine. So we're fine there. So now the next thing I need to do is I need to get my Linux stable. So the way I'm going to do this, I'm going to use another. I need to check out the Linux kernel, the latest Linux kernel. So we can do that by doing git clone git.kernel. So git clone git.kernel.org/pub scm linux kernel git stable linux stable.git. So we're going to create a new directory here and clone our kernel source into this directory. So this is a sizable download. I think this is somewhere between 500 megabytes and 1 gigabyte of a download. Okay, so that's finished downloading. So now I have two directories. I have a Linux dev and a Linux stable. See how big they are. Linux dev, okay, it's sizable enough. Okay. So go into Linux dev. And now I have to go through a few steps just to set up to build this particular application. So let me just have a look at this step. So I want to set it up for the Beaglebone. So we just have to copy I have to set it for my system. So there's a system sh sample to system. Okay, I'm going to vi. Okay. So there's a few things I have to do here. So we're going to cross compile this. So I'm going to uncomment this. So we want cc equals arm linux gnu ABI. We also want to build, let me see what else we've got to do. We've got to specify the direction, location for our stable. So this is going to be tilde slash Beaglebone slash Linux stable in my case. We're going to build for the Beaglebone, so we have to uncomment this, ZRELADDR, this is the address. I think that's it. So escape :WQ. System.shell. Yeah, those changes are all made. So let's just see what happens now. So I have my system.sh, so we're going to try and build this and see what happens. I don't know if I have the right tools installed, but let's try anyway. /build kernel. Failed dependency check. Okay, so I have a few things I need to install. So for Ubuntu, we've got to install we need uboot okay. Okay, so we've installed those 3 packages. Try again. Let's try again. Okay, we're still missing more. Build essential we need. Remember, I've started from a completely fresh and blank installation of Ubuntu, so just to make sure that I'm covering all the possible steps. So these are the type of dependencies that you probably have installed already if you've done any sort of compilation on your machine. Like this is installing G++, GCC and so on. So you probably have these tools already, but just in case, just go through all the steps. Okay, try again. Okay, it's looking good. Okay, so v3.2 PSP14 is the branch that we're building on. Okay, this is the kernel configuration tool, and this is where we can check certain things. I just want to check to see that we've got networking device driver. Okay, for SPI support, I'm just going to enable debug support. So I'm just going to enable debug support for SPI drivers. I2C support, just see. Everything is perfect. I don't think there's anything else. If there was anything else, you can go through this. This is substantial. It's a great tool, but you can go through this and see if there's anything else. So we're going to exit this. This is ready to go. We'll save this configuration, and off we go. So it's going to take a while now for it to compile all these sources. So I'll fast forward to pretty much the end unless anything happens. Okay, so that has built the full kernel. It didn't take too long on the machine actually. It took about 10 minutes there this time. So I was using multiple cores and it's working fairly well. So this should be in my kernel directory. Yeah, so everything seems to be built correctly. So the next thing we want to do is to deploy the kernel to the installation. So I've just placed the SD card into the micro SD card into an SD adapter. I'm just going to plug this into my machine. Oh no, it's there. Okay, so here it's appearing as SDE, VFAT. So it's popping up there. Okay, so we want to deploy this. We might need further tools. So we're in the same directory. So we need to go into tools. And we want to install the image. So I'm pretty sure that I fixed that time. Let me just go into my system. SDE, so I need to edit that. Okay. So let's try and install the image. So this is an existing angstrom distribution. So I'm going to deploy the kernel to this distribution here. Modules. So this is a 3.2.5 plus distribution. Okay, kernel. Okay, so let's look at, so let's see what the effect that has on if I deploy this. Okay, well we might need, there might be additional dependencies required here. Okay, what are we missing? Oh. I think we must have to execute from here. Okay, so you have to execute it from your Linux dev root. So it's /tools/install. And it's telling me that it's /dev/SDE is where I've got it set up. Are you 100% sure? Yes, I'm 100% sure. So we'll go yes. Oh, okay. 3.2.18 PSP14 to boot. Okay, so that seemed to work well. Okay, so let's come back. So we go lib, modules. You can see now that we've got a 3.2 18 minus PSP modules directory. So this means that this is likely working correctly. So we'll boot this angstrom distribution first of all and see that everything worked correctly. So I'm going to eject. Okay. So I'm going to plug this in to my Beaglebone. And plug in my network cable. And power my Beaglebone. Okay. So this is my, I just opened a secondary Xterm here just so I can SSH into the Beaglebone and check that everything's working correctly. Okay, so it's SSH. I'm logging into this one as root. Okay, so you can see I'm logged into my Ubuntu, and you can see here, yeah, worked correctly. You've got, see that we've now got our build 3.2.18 minus PSP 14. So that worked well. So that's deploying a new kernel to an existing deployment. So this is using the Angstrom distribution and just updating the kernel on this. The advantage now is that because I've built the kernel here, it means that if I have to make any further changes, it's very easy to recompile the kernel. What are the steps if we want to use a Ubuntu distribution? So if I'm to take a card, how do I take a card, a blank SD card, and put a full Ubuntu installation on it along with this new kernel? Okay, so the next thing I want to do is deploy this with a minimal Ubuntu installation. So the way that I'm going to do this is, first of all, I'm going to go to this site here, rcn-ee.net deb/rootfs honoric, and you can see here we've got a link. So just let me try and get this. I'm just going to paste that into Notepad just so I can see it. Okay, so that's the full path. Ubuntu 11. Okay, let's try it. Okay, wget http w blah, 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 blah. Oh, hold on. Flip. Okay, I don't want to do it here, so I don't want to download it. So Beaglebone. So try this. Just do the same path. Okay. The way that I just pasted that in there into my virtual machine, in VirtualBox, just the middle mouse button, pressing that. So it says -B. So on tar. Okay, so we've got a directory. Okay, so this is what I'm going to deploy. Okay, SDE. So this is an old image that I have on that Angstrom Cloud version. It's an old image, so I'm gonna probably delete that and reinstall. Okay, so this is a list that I assumed I needed a load of dependencies. So I'm missing PV. There were loads more. Let me see, there was PV. I have wget. see if there's any other dependencies. No, it seems to be working okay. Okay, that seemed to work. Okay, so there's my 2 installs. So let's boot into the Beaglebone. So I'm going to place this SD card in. I still have to deploy the new kernel. Okay, so it's coming up as 167 on my network adapter. So let's try and SSH into it. We should get we should probably have a problem here. I think that it was a 167 the last time, and in this case it's Ubuntu, so we want to log in as Ubuntu. Oh, host key warning: host identifications changed. It's possible that someone is doing something nasty. That's me. Fingerprint has changed. Now the reason for this is because we've rebuilt the installation. It's been given the same IP address, but it has a new fingerprint. So we just need to register this fingerprint with our... Oh, it even tells us how. Okay, let's try that. SSH minus keygen. Okay, so that's seems to have worked. So we've removed the previous key. So let's try and SSH in again and log in as Ubuntu. Yes, we're sure this time. Okay, I'm Ubuntu. Okay, password is... What's the password? I'll try Ubuntu. No. Okay, I'm going to have a quick look to see if I can find the password. The password is temp pwd. Oh, good God. Okay, so after a search of the internet, I found that for this particular distribution, the default login is Ubuntu and temp pwd. TMP PW. No, sorry. TEMP PWD. Okay, so I need to change that. Okay, password updated. So, as you can probably guess, we now have a Ubuntu installation on this card. And it's 3.2.18 minus PSP 14, so it's very up to date. We have built our kernel, which is very useful, and we have built it for SPI support. So I'm still going to go and put this back into the. I'm going to put this back into the PC again, so that I can deploy my kernel I built. So I'm going to do that. So shut down. Okay, so I shut this down and I'm going to place the card back into my card reader again. So everything's going well so far. Okay, so there's my directory, so not too bad. Now, where's my... I thought that would have come up by now. Oh, it is there. SDE is there. Okay, So I'm going to back into my Linux dev, and I'm just going to deploy my new built kernel again. What was it called? Install image. Okay, so even though it's the same build, I'm just going to deploy it to the boot partition anyway, just so that we can be sure that we have our SPI support and whatever other changes you wanted to make to your kernel when you were building it. Okay, so again, I'm just going to reboot again. Everything should be fine. Look at my Beaglebone. I'm going to give it a second. Okay, my LEDs are flashing. Okay, I was a bit early there. Try again. Okay, it's asking me for my password. Okay. Okay, so everything's working. That's my newly deployed kernel that I've built. Everything's working perfectly. Yeah, everything is there. Okay, so everything looks like it's there. So if we go into slash, let's just check this. Okay, everything looks to be there too. I2C adapters. Let's just go into the LEDs for a second. Okay, so the trigger is there. So say we wanted to put a heartbeat onto the trigger. Under Angstrom, we could have just said echo but under Ubuntu we can't do this because we have to do sudo. Now the problem is we can't just go sudo echo either. Because we still have access denied because of the way it's built on top. It's one command built on top of another. So we could do something like this. Oh, sh minus c. Okay, now I can confirm that works on my Beaglebone. I've got a heartbeat on the third LED, so it's flashing in the same way, not necessarily at the same time, but at the same way that user LED 1 is flashing as well. Okay, so you can see that using Ubuntu, it can be a little bit more awkward for some things that are quite straightforward on Angstrom because of the way that you have to use your super user do setup. Okay, what else have I got to go into now? Okay, so the next thing I want to do is go on to the wireless adapter, to the network card. And I've plugged in my network adapter. This is I've pulled in the Edimax one. So I do ls USB, and you can see that at the moment I've got my device attached, bus 0, Edimax, yeah. And it's Realtek RTL 8188CU. Now from reading documentation on this adapter, you can search for this adapter, it's compatible with the RTL 8192CU. So that's what's available on this particular device. So if I go into cd/lib firmware, RTL Wi-Fi. You can see that when we built the kernel, we have built-in kernel support for the RTL 8192 CU FW bin. Okay, so we have built-in support for this. Okay, so you can see that that's been picked up here. So the RTL Wi-Fi and so on is working correctly. Now, what's next? Well, if I go into CD slash, where's my network setup? Oh, I'll see if I have my tools. Hold on, let me see. I don't have my tools yet, so I do have them. Okay, so USB, Ethernet 0, L0. So we don't have network adapter turned on at all for this particular device, even though it is present. Okay, so we need to do that first. Okay, so that's my standard Ethernet, Ethernet 0, and my loopback. So I need to go into network. Okay, so I'm going to edit this. Interfaces. I won't make it auto yet. Oops. Oh yes, of course I have to. Okay. Interface wireless LAN 0 iNet DHCP, and I'm going to connect it to my network. Okay. I need my WPA password. Okay, which I'm going to hide from you. Okay, that's my WLAN escape colon WQ. Okay, now let's see what happens if I say IF up sudo. Okay, cannot find device WLAN 0. I'm going to try and reboot this device first of all before I go any further. Okay, that's working a little bit better this time. It's setting up the frequencies. I'm just going to widen this and so I can let's do that again. Okay, so let me see. RTL 8192CU. It's got its MAC address, port type 0, frequency set up. Okay, Ethernet 0 link becomes ready, and let's try it now. IF up sudo. Okay, so it's trying. The blue light has come on my adapter. I could, oh, wait, running. Okay, auto on, okay. Loading firmware, correct. Wireless LAN 0, authenticate, try 1, authenticate. Associated. Everything looks good. Yeah, everything looks very good. Open working. picked up my network. Everything seems to be right. So let's just look. So do that again. ifconfig. Okay, seems to be right. Now I'll go into this machine here. This is my PC. So if this is this is on 167. This is my fixed Ethernet. So if I want to connect to my wireless Ethernet, I have to 168.1.168. So SSH. It's working. Okay. So if you've made it this far in watching the video, well done. The other thing to mention is that if you want to get the adapter to start up automatically, just edit the /etc/network/interfaces file and add the line auto WLAN 0 in front of your adapter configuration. That way it will start up automatically. So that's it really. I've built the kernel using the great guides that are linked to this video, and I've deployed a Ubuntu minimal ARM distribution, which has resulted in Wi-Fi support. If your adapter is not working, then you'll need to download drivers directly from the Realtek website, and that's when you'll need to do the following steps. Search for the RTL. Keep going down. 8192 CU. Here we go. US. Beginning FTP transaction. What? Save file. Okay, I'm going to extract this to an ID, Beaglebone, create folder. I'm going to call this the 8192 CU and extract here. Okay, close that, minimize it just in case we need to go back. Here's my Xterm. Okay, CD Beaglebone. Okay. So we want to compile the driver. So I'm going to go into the driver directory. Oh, it's zipped up. Okay, so it's doing it. The auto install works fine, but I need to cross compile it. So I'm going to have to manually edit the make file. So let's unzip. Untar. Okay, oh, what a path. Okay. The path's a bit long. Okay, what do I do next? I need to edit the make file. So that I can set it up for cross compilation. Okay, so I'm going to do that here. Okay, so we're going to 8.3.5.17 Android. We'll create a new configuration. So no, we're not going to compile for PC. Beaglebone equals yes. Okay. Oops. DD. Okay, so I've got my Beaglebone platform is configured yes. So let's create new configuration. So go down till we find the configuration for i386. Config. Everything else we'll leave as it is. So there's the first one. If equal config i386 yes, config little endian. Okay. So we need to add one in here now. If equal dollar okay, if equal, and we'll just end the if just to be sure. Oops, I have to keep forgetting I'm in VI. Okay, so we need to just edit this a little bit. To do the same as the config, same as the i386 little endian. So we're compiling for ARM, and we want to say we want to use ARM Linux BI. So where's the kernel source? K, oops, A, K, S or C. Where is it? /home /Malloy? No, /home. Where am I? Yeah, it's Malloy D, isn't it? /Beaglebone. Beaglebone. Home Malloy D Beaglebone. And I put it into a directory. What did I call it? A Malloy D / escape : UQ. Make. What's wrong? Line 258. I've made a mistake. Line 258. Any idea where I am? Just let me check my text that I've done it right. Oh, what the, okay. If a equal config platform Beaglebone yes, extra flags plus equals. I think that, let's try it. Make. Okay, it's doing something. It's looking good. Looking very good. Okay, that succeeded. So I've got my module compiled. So there's my module, 8192cu.ko. So we can take this. Linux dev, let's take it. Okay, driver, RTL. Let's compile. compiled correctly. 8192CU, copy this and place it on our rootfs lib modules, where this device, we've built it for that device, kernel, drivers, net, wireless, RTL Wi-Fi. We'll paste it in here. Once you boot it, you have to remove the existing driver, so you have to unload the existing driver. Sure, I'll do it. I'll 167. Okay, so I haven't got automatically I haven't turned on that oh, flip, I never plugged in the card, the network adapter. Okay, network adapter's plugged in. So, if we want to decide to blacklist the driver, the existing driver, so we can use mod probe. Now, let me see if we can. We want to blacklist the existing RTL driver, so we would go into cd/etc/mod probe.d black. Okay, we'll do that here. And we want to blacklist it, so we can go sudo vi. So again, you'd only do this if the kernel driver wasn't working. So we can put it in here. Okay, so we've blacklisted this device, so I'm going to reboot it and see what happens. Oops, small R. Okay, so let's see what happens. I've logged back into my Beaglebone. So there's no mention of there's nothing mentioned there to tell. So we can do USB to see that the device is attached. Okay, 8188 CUS. So let's mod probe our new device driver. I think I've a step to do before I do this. Yeah, fatal not found. The last thing we have to do is we have to update the kernel modules dependencies. So we'll do that by just typing we'll have to do sudo sbin/dep mod -a. Okay, I think I got the password right. Maybe not. No, I must have got it right. Okay, so this takes a minute. Okay, and I'm back. So now I can do mod probe 8192CU. Oh, with super user access. Okay, sudo mod probe 8192CU. Message to see what's going on. Okay, a few funny messages. Okay, I'm going to connect. I've rebooted my device. I'm just going to log back in. So IP address 167. Message. Okay, it's associated. Good news. So if I do an ifconfig, yeah, I can see that I have my IP address for my fixed line. My wireless 1 adapters come up. It's 169. So I can just do, well, let's just, what do I do there? Control Z, BG, X term. Oh, I mistyped it. Okay, so let's just do prove it. We can secure shell into 169. Yeah, all working. Yeah, same device. Everything's working perfectly. So that shows that I've just gone through the steps there. Now, you may not, hopefully you don't have to do that. You don't have to recompile the device driver. But look, what I've done there is just gone through the steps of showing you how to actually compile and install a device driver that you download directly from the website rather than using the kernel version. You may need to do that if the kernel goes out of date, or if the kernel driver goes out of date, or if there's specific features that you need that are only available from the official driver from the website.